students. Welcome to another basic science class. Today we want to consider forces. What is a force? A force is any action that moves an object. So whatever you do to an object to make the object move from where it was to another place, that thing that has made that object move is what we call force. Force applied to an object can cause the object to move. Definitely, take for instance a car that is spoiled, parked somewhere, and you decide to push. When you push that car, even without igniting the engine, you discover that the car will move. Why? Because you've exerted a force on the car. So you should know that anything that is exerted upon by additional force or additional pressure will cause that object to move, and what you have done is a phenomenon we call force. The greater the mass of the object, the greater the force required to move it. If you are asked to push a very heavy stone from its position to another position, if that stone is very big, that means you need additional strength. You need more mass in order to push that stone away from there. That's why we say the greater the mass, the greater the force. So the bigger the object, the bigger the force, or the force you exert on it so that it can move. Now, force can be mathematically represented. So force is known in mathematical symbol as F, capital F. And F there is equal to, so force here is equal to the mass times acceleration. The mass here is the weight of the object, and acceleration is the ability to move that object from where it was to a new location. So in a nutshell, F being force is equal to mass times acceleration. The SI unit, what we mean by SI unit is International System of Units. So it means that whatever is written here in Nigeria, like we said, force is F. Go to America, go to Europe, is the same thing. So that is why it's an internationally accepted unit. So the SI unit for force is Newton. Newton is the name of the scientist that discovered this. In the course of these studies, I'll tell you a little about Newton. But let's look at some mathematical applications of force. Let's consider example 1. The question says, calculate the force on an object of mass 500 mg, which produces an acceleration of 400 centimeters cubed. So how do you go about this? Do not forget that we are looking at force, we need mass times acceleration. Now let's look at how to go about this. The unit of mass and acceleration in the question is grams and centimeters. You can see that the unit given here is not the same unit given in force and acceleration. So there will be need for conversion. So they've given you grams and centimeters. So you need to convert these grams to kilograms and centimeters to meters per second square. So hence, how do you convert that? You know that in our elementary mathematics that 1,000 grams is equal to 1 kilograms. So in order to convert this 500 milligrams into grams, you have to divide it by 1,000. So that's how we have 500 grams divided by 1,000 to give you the unit in grams. So when you do that, you have 0.5 grams. That is not all. You have succeeded in converting this to the required parameter. Now let's look at acceleration. Acceleration is given in meters per second square, but from our question, it's given in centimeters. Thus, you need to convert these centimeters into meters. So 100 centimeters is equal to 1 meter. So in that case, you have to divide this 400 by 100 to get the required parameter. So 400 divided by 100 will give you 4. So with this now, we have arrived at our required parameters. So force is equal to mass times acceleration. We calculated the force to be the mass to be 0.5 times the acceleration to be 4. So when you multiply that, you have 2 kilometers per second squared. So that should be written in Newton because the International System of Units for force is Newton. So the force that will be needed to push the mass of that will be 4 Newton. You can see that it's a straightforward calculation. I want you to try it over and over again. If you have any problem with the conversion, you let me know through the same medium. Now let's proceed. A force can cause an object with mass to change its speed or movement. When you push an object, you can cause the object to change to the position or direction of your own desire. We can also say that a force is a push or pull upon an object resulting from the object interaction with another object. So it can be either a push or a pull. That is equally force. So let's look at types of force. Force can be divided into two, or it's made up of two types. We have contact force and we have non-contact force. From the word contact force occurs between two bodies making contact with each other. When two bodies make contact with each other, in fact, when there is a contact, we say that that type of action or force is called a contact force. Examples of contact force include frictional force, air resistance forces, push and pull, applied forces, etc. Now let's look at this diagram. This is the hand of somebody trying to push a little box placed on the table. So because there is a contact, you can see the hand touches the box. That makes it a contact force. And as you are pushing, there is an opposition. There is a force that is opposing it to move freely. That force that opposes this box to move freely is what we call friction, or you call it frictional forces, which we are going to look at in our next episode. Now let's look at friction. Friction is a force that opposes motion. Now, so I told you as we were looking at that diagram, I said when you push the box could not move freely as you inserted a force on it because there is some forces that is making it to stand. So that force becomes a friction. So when there's that force between two surfaces which do not allow free movement, we say that that is friction. So now I want you to do this little work for me before we get into the part 2 of this topic. What is the SI unit of force? Now try this calculation. Calculate the force which is required to move an object of 500 grams to a distance of 4 meters. What will be required? Remember the formula for force. Force is equal to mass times acceleration. So put that parameters into V and let me know the force that will be required for you to push this in this distance. Finally, name the various types of forces. Name the various types of forces, and when you do that, in our next class, you let me have the answers. So I'll take you now to part 2 of this lesson. Thank you.